Hashtag Movile Cave. Posted. Oh, hey, didn't see you there. I'm Dr. Justin, otherwise known as the most amazing biologist in the world. And here is my trusty sidekick, Dr. Celeste.
I prefer assistant, but thanks anyway, Dr. Justin. We are here at the Movile Caves in Romania. But before we can explore, let's do a brief overview of this wondrous site, shall we?
This cave is 20 meters below Earth's surface, and thick layers of clay prevent any sources of sunlight to filter through.
So, if there's no obvious light source, how do autotrophs make their own food? The air in the cave has half of as much as the oxygen, there being 7 to 10% compared to our 21 on the surface of the Earth. There is also 100 times more carbon dioxide, there being 2 to 3.5 in the cave compared to our 0.03 on the surface of the Earth.
So how do the organisms in this cage live in such a toxic environment?
What are you doing here?
There are many unanswered questions about this mysterious cave.
So, let's dissect our questions to see if we can find any answers.
Good thinking, sidekick. Let's go.
It's assistant. We're in a cave near a lake that inhabits many unique organisms.
Yes, there have been 43 organisms discovered in this cave, and 33 that were previously unbeknownst to this world.
The lake water is covered by autotrophic bacteria that uses chemical synthesis to make chemical reactions involving toxic gases.
Such as hydrogen sulfide to make their own food.
So, any other information?
You know it. The reaction involving the gases produces sulfuric acid, which erodes the walls of limestone. Let's go, sidekick.
Assistant. Let's look for some organisms that live within the cave.
Oh, look over here.
Whoa!
This insect barely has any pigmentation.
That's because they haven't been exposed to the sunlight for at least 5.5 million years. Look at its limbs and antennae.
I think that's a result of them living in a pitch black cave.
I see. They use their antennae and long limbs to navigate themselves.
I see. Let's go, sidekick.
Assistant. After we visited the cave and studied some of the organisms that live there, we wanted to go back to the lab and elaborate on those studies. For example, the evolution of the woodlice.
Great idea. Let's take a look at the phenotype of the first woodlouse. It has bigger eyes, darker skin, and shorter legs.
And look at the woodlice that evolved sometime between 0 to 5.5 million years. It has lighter color pigmentation, shorter legs, and medium-sized eyes.
Lastly, the woodlouse of Movile caves today has little to no pigmentation, barely any eyes, and long limbs. What has caused an evolution so drastic as this one? And I wonder what it's called.
I believe that's called selective pressure, which is any phenomena that alters the fitness or behavior of living organisms in the same ecosystem that interact with the affected organism.
I guess that's it. Thanks, sidekick.
You do know that it's pronounced assistant, right? And where are you going? What is this?
Oh, a few months ago I started studying selective pressure.
Oh, really? What'd you find out?
The phenotype of woodlouse came to be because the environment it lived in was dark. Similar to how strong sunlight is a selective pressure that favors dark-skinned people. Lighter-skinned people have a disadvantage in these kind of regions.
Oh, and they evolved because there's no need for eyes in darkness.
Exactly. Thanks, sidekick.
Assistant. Hello, it's me again. The air in this cave...
No!
What is this?
This is my board.
After we visited the cave and studied
I need to look at my lunch.
there was also 100 times more carbon dioxide on... Wait, I messed up.
Lastly...
Oh, are we actually starting? Range policies. Toxic gases, it's toxic gases!